for my final project, I've decided to go with phylum Anthroptera. It's a really diversified phylum, and it's actually the largest phylum in the kingdom Animalia. And yeah, so we'll go on to the slide number 2. Classifications of the phylum Anthropoda. It falls under the domain Eukarya. Kingdom would be the Animalia, and the phylum is of course the Anthropoda. And then it divides up into 4 different subphylums, which are the trilobites, Eunermia, Calstria, and Crustria. And then it would divide up into even more different groups for class, which are 5 different classes. And so for the 4 different subphylums, trilobites are basically extinct right now. For Eunermia, those are the basically all the insects and like butterflies and species like those. And then for the subphylum Calstria, those are basically all the species like spiders, scorpions, mites. And then for the subphylum Crustria, those are all the species which are in marine. So marine members, which include shrimp, lobster, crabs, and so those are all the classifications for the Anthropoda. And if you see this chart over here, you would see all the images and be more able to look at how the classes are divided up into and what class falls under which subphylum, right? So yes, so those are the classification for Anthropoda. For this phylum, one thing that is similar um, to all the classes and all the subphylum is that they all are segmented. If you see this diagram over here, the picture over here, you can see that they're all segmented, and the segments can be different numbers. So um, this insect has 3 segmented, but that means that the common ancestor was segmented as well, meaning that it had their torso, their abdomen, their head, and that really tells a lot about the ancestry. And looking at the history for this phylum, it goes way back to Cambrian period, and the first evidence was collected by looking at the fossils of trilobites. And so that was the first evidence for this phylum. And the closest relative of anthropods is annelids, due to having the similar segmented body. And so that is the main characteristic for this phylum as well, that they're segmented bodies, which are invertebrates. And yeah, so that's basically the ancestry for this phylum. Any key characteristics to um, phylum Anthropoda. So to start it off, they're basically bilaterally symmetrical, which means that if you were to draw a line between this crab, it would look same for the left side and for the right side. They are also triploblastic, which means that they have 3 layers for their cell layers, and they're also metamerically segmented, which is one of the key characteristics, which basically means that it has their head, abdomen, and torso, which follows for all these species. Doesn't matter if they're marine species, even if they're insects or they're land species, they all have that in common. And so all the anthropodas are invertebrates, which means that they don't have the support, and in order to um, in order to support their internal bones, they basically have exoskeleton to compensate for the arthropods being invertebrates, and so they produce a hard exoskeleton which is made out of chitin, which is basically a mixture of lipids and carbohydrates and proteins, which protects their body like an armor. So, um, yes, that's also a key characteristic for these for this phylum. And so they all have joint appendages, and if you see over here, it's evident that you can see it. Their appendages are used for different needs. Some are for sensing, some are for locomotion, some are for feeding, and yeah, they have open circulatory system, which means that their blood isn't pumped through their veins or capillaries. They like humans. Their blood is pumped through open space. Genetics constraints for this phylum is that it has exoskeleton, which basically means that if the species wanted to grow, it had to molt. Molt is basically when species the all the species shed, and at this point they are most vulnerable to getting attacked by predators, and that basically slows down the growth of the organism and leads to slow evolution. They are also bilateral symmetrical, which leads to lack of evolution, which slows down evolution as well at the end. History of arthropods. Um, One thing that is key for the history is that the trace fossils, and looking at the trace fossils, trilobites are the most they're basically the foundation for this phylum, and they go back to like Cambrian periods, which is like 500 million years ago. And yeah, so trilobites are extinct, but their fossils tells us lots about the phylum and how they evolved from 500 million years ago. On to the citation. These are all the citations that I've used in my presentation. Thank you.